Hello there, and welcome to Mr. Sleepy Science. I'm truly glad you found your way here. Maybe it's been a long, tiring day. Or perhaps you're someone who prefers drifting off to thoughts about the cosmos and deep mysteries instead of counting sheep. Either way, tonight's adventure is meant just for you. You don't have to do a thing now. Only rest. Let your thoughts loosen, your breathing settle, and your body grow light, as if gravity itself has eased its grip. Because tonight, we're not just gazing at stars. We're gliding quietly through our home, the Milky Way. A vast spiral made of stars, dust, and unseen matter spinning gently through space for over 13 billion years. But beyond its beauty lies mystery, rogue stars, invisible forces, and ancient remnants that defy what we thought we understood. We'll journey softly, from its shining spiral arms to its hidden secret core, from colossal collisions to ancient stars older than the galaxy itself. You'll hear about black holes, star nurseries, and the unfinished story of a galaxy still growing. Some of what you hear tonight might surprise you, or at the very least, awaken a little spark of wonder as you drift off to sleep. And before we begin, if these calm explorations help you unwind or give you a peaceful way to end your day, consider liking and subscribing to Mr. Sleepy Science. It helps others find their way here too, one sleepy soul at a time. Now, let's begin. The living galaxy. The Milky Way has collided with other galaxies before, and it will again. It may feel like a stable, quiet home, but in truth, it's built from the remains of many others. Across billions of years, it has absorbed smaller galaxies, drawing them in, unraveling them, scattering their stars into long, glowing streams that wrap around its edges. Even now, the Sagittarius dwarf galaxy is being torn apart. And far in the night sky, Andromeda drifts ever closer. In about 4.5 billion years, the two grand spirals will merge in a slow cosmic collision. No stars will crash into one another, they're far too spread apart, but the shapes of both galaxies will change forever, folding into something vast and new. Even galaxies are not eternal. They evolve, collide, and begin again. Ancient stars, older than home. Some stars within the Milky Way are older than the Milky Way. Not all were born here. Some ancient, metal-poor stars wander in long, tilted orbits, relics from a time before our galaxy had fully formed. Astronomers believe these ancient lights came from smaller, early galaxies that merged with ours long ago. Their chemistry reveals almost no heavy elements, meaning they were born just after the Big Bang. They drift high above the galactic plane, moving slowly, like quiet spirits from a wilder, younger universe. In their light, we glimpse an era when the cosmos was still learning to become what it is today. Our place in the motion. Our solar system moves around the Milky Way's center at over 828,000 kilometers per hour. That's more than 230 kilometers every second. Even at that speed, It takes around 225 million years to complete a single orbit. We call this cycle a galactic year. In all of Earth's history, we've made the journey only about 20 times. When the first dinosaurs appeared, our solar system was in a completely different part of the galaxy. The stars you see overhead tonight weren't always near us, and they won't always stay. Everything is in motion, quietly, endlessly. Even as you rest, the Earth spins, the moon circles, and the solar system sweeps forward through a galaxy in motion. A galaxy that still grows. Though ancient, the Milky Way is not finished. It still gathers material, gas from intergalactic space, stars from smaller galaxies, and invisible streams of dark matter feeding its halo. Sometimes this happens gently, as soft clouds drift inward. Other times violently, as entire satellite galaxies are torn apart, their stars scattered like whispers across the sky. The galaxy we live in now is not the same one the dinosaurs saw, and the one our distant descendants may know will be larger still.
The shape we cannot see. We don't truly know how many arms the Milky Way has. It sounds like something we should know. How many spiral arms reach from the center of our own home galaxy. But from our position, deep inside the disk, it's almost impossible to see the full structure. Thick clouds of dust block our view. Stars blend together until the pattern blurs. For decades, astronomers thought there were 4 main spiral arms. Newer studies suggest there may be fewer, or that the arms twist and branch in ways far more complex than we once imagined. Some arms fade into fragments, others wind around unexpectedly. The Milky Way may not be a neat, symmetrical pinwheel at all, but a living swirl of stars, shaped by gravity, time, and invisible motion we still don't fully understand. Rogue stars flinging into the dark. Most stars move peacefully through the galaxy, but a few are torn from their homes, flung outward at unimaginable speeds, fast enough to escape the Milky Way entirely. These are hypervelocity stars. Some are what's left when a pair of stars strays too close to the supermassive black hole at the galactic center. One is devoured, while the other is hurled outward, shot into the void at over 1 million kilometers per hour. These rogue travelers drift alone through the dark, glowing faintly as they vanish into intergalactic space. Even in a galaxy bound by gravity, there are rare, violent moments of release, silent expulsions that send the stars flying into the endless night. The coming collision. High above our horizon lies Andromeda, visible to the naked eye as a faint smudge of light. It's a spiral galaxy like our own, vast, majestic, and slowly approaching us. In about 4.5 billion years, the Milky Way and Andromeda will meet. It won't be a fiery crash, but a slow, graceful dance. Stars will glide past each other without colliding, but gravity will twist both galaxies into long arcs of light. Their shapes will stretch and blend. Tidal tails will curl outward like ribbons. Their black holes may spiral together, merging into a single massive heart of darkness. And after billions of years, a new galaxy will form, calm, vast, and eternal. The story of our home will begin again, written across the stars. Stars that move against the stream. Most stars in the Milky Way orbit the center in the same general direction, but some go the other way, orbiting backward against the flow. These retrograde stars, found mostly in the outer halo, likely came from other galaxies that were swallowed long ago. Their reversed motion is a quiet signature of their foreign past, as if the galaxy itself remembers every merger, every collision, every guest that ever joined its slow rotation. Our galaxy doesn't just hold stars, it holds memories, ancient ones, moving silently against the tide. A galaxy built from others. Over billions of years, the Milky Way hasn't grown alone, it has consumed. Small galaxies drifted too close, were caught in its gravity and slowly dismantled. Their stars were scattered into streams and halos, stitched into the greater structure we now call home. Astronomers have even identified some of these ancient mergers by studying how stars move and what elements they contain. One major event, the Gaia-Enceladus merger, reshaped the early Milky Way. Our galaxy is not a single creation. It's a composite, a masterpiece built from quiet collisions and the remains of countless smaller worlds. Chemistry that tells time. Every star carries a chemical fingerprint, a unique pattern of elements imprinted at birth. By studying these fingerprints, astronomers can trace a star's origin, where it was born, what kind of cloud formed it, and even what galaxies merged to create its neighborhood. Some stars are rich in heavy elements like iron and calcium, formed in later eras when the universe was mature. Others contain only the simplest ingredients, hydrogen and helium, born when the cosmos was still young. In this way, chemistry becomes a time machine. Each element tells a story, each pattern a poem written in light. Through them we read the hidden history of how the Milky Way came to be. Ghostly ribbons of light. If you could see the sky in perfect darkness, you'd notice something astonishing. Faint, thin ribbons of stars arcing across the heavens. These are stellar streams, the remains of small galaxies that were torn apart by the Milky Way's pull. Their stars now stretch into delicate threads, tracing ancient orbits that loop around our galaxy. Some wrap around like halos, others dive inward toward the core. They are evidence of the galaxy's past collisions, soft reminders that creation and destruction move hand in hand. Like rings in a tree, the Milky Way carries its past in every line of light. The galaxy isn't flat. Though it looks like a perfect spiral in pictures, our galaxy is warped. Its disk bends upward on one side and downward on the other, forming a gentle wave through the stars. This subtle warp went unseen until radio telescopes mapped the hydrogen gas that extends beyond the visible edge. Scientists think the bend might be caused by small satellite galaxies tugging at the Milky Way's edges, or by lumps of dark matter pushing from below. Even galaxies are not perfectly still. They flex and ripple, bending gracefully over time. From afar, the Milky Way might look as though it's slowly dancing through space. The ocean of stars we can't see. Under a clear night sky, far from city lights, you might see a few thousand stars and the pale band of the Milky Way stretching above. But that is just a tiny fraction of what's really out there. What we see is less than 0.0003% of the galaxy's true stars. The rest are hidden behind dust, too faint or too distant for our eyes. The glowing streak above us is only the inner whisper of something far greater. We live in a colossal river of starlight, so vast we can barely comprehend it from within. The motion of the stars. Unlike planets that orbit their sun in neat circles, stars in the Milky Way follow individual paths. Some race quickly through the inner regions, others drift lazily along the outskirts.
This difference in speed gives rise to the spiral arms, not solid structures, but waves of density moving through the galactic disk. As these waves pass, they compress gas and dust, triggering bursts of star formation that light up the arms in curls of blue and white. Our sun is one of these travelers, moving slowly through the galaxy's spiral flow, in and out of patterns that shape the sky above us. The Milky Way is not a machine, it's a current, and we are drifting within it.
The invisible glue. By all logic, the Milky Way shouldn't hold together. The stars at its outer edges spin far too fast enough that they should be flung into space like sparks from a wheel. And yet, they stay. Something unseen holds them in place, something that outweighs all the visible stars, gas, and dust combined. That something is dark matter. It doesn't glow, it doesn't reflect light, it passes through everything like a ghost. But its gravity is undeniable. It's the invisible framework that gives our galaxy shape, the quiet strength that keeps every star bound within its orbit. Without dark matter, the Milky Way would scatter apart. With it, the galaxy hums in balance, spinning on the edge of mystery. The sleeping giant at the center. At the very core of our galaxy lies a supermassive black hole called Sagittarius A*. It's more than 4 million times the mass of the Sun, yet smaller than Mercury's orbit. We can't see it directly, only the way nearby stars race around it in dizzying tight circles, their motion tracing the gravity of something invisible and immense. Sometimes, gas and dust fall inward, flaring with X-rays as they spiral toward the event horizon. Today, this giant rests quietly, but long ago, it may have blazed like a quasar, lighting up the heart of the Milky Way with furious brightness. Now it slumbers, the silent conductor of a slow, endless dance of stars. At the center of everything, gravity sleeps. The galaxy's strange shape. When scientists mapped the center of the Milky Way, they found something unexpected. The galactic core isn't perfectly round. It bulges outward like a three-dimensional peanut. This shape likely formed from a dense central bar of stars that slowly buckled upward over billions of years, twisting the heart of the galaxy into an hourglass. From the side, it looks like a glowing flame, narrow at the ends, swelling in the middle, shimmering with billions of suns. Our galaxy, for all its beauty, isn't simple or clean. It's alive with motion, sculpted by gravity's patient hand. Where stars are born. The spiral arms of the Milky Way aren't made of stars alone. They are woven from stellar nurseries, vast clouds of gas and dust where new stars are born. When these cold clouds pass through the denser spiral arms, gravity compresses them, igniting waves of creation. Bright young stars flare to life, bathing their surroundings in ultraviolet light that paints the arms in soft blues and silvers. Every star you see, even our sun, began in one of these nurseries, long ago, wrapped in mist and quiet fire. The galaxy breathes through these regions, creating, fading, and creating again. The halo beyond. Beyond the bright spiral disk lies something almost invisible, the galactic halo, a vast sphere surrounding everything. It holds ancient stars, globular clusters, and enormous amounts of dark matter. Though dim and diffuse, it contains much of the galaxy's total mass. Its stars move slowly and far apart,
tracing the quiet outer rhythm of the Milky Way. The halo also preserves the remnants of long-ago mergers, streams and shells of stars that once belonged to other galaxies. It is the Milky Way's memory, faint but enduring, still shaping what the galaxy becomes. The oldest star cities. Scattered throughout the halo are over 150 globular clusters, ancient golden spheres of tightly packed stars. Each cluster contains hundreds of thousands of suns, bound together in a perfect gravitational harmony. Some of these clusters are more than 12 billion years old. Their stars formed before the Milky Way itself took shape. Their light carries whispers from the earliest days of the universe. They drift above and below the galactic plane like glowing embers, patient, unchanging, timeless. A galaxy still in motion. Even now, the Milky Way continues to grow. It gathers gas, captures stray stars, and pulls in faint galaxies that wander too close. Sometimes it grows quietly, as thin streams of hydrogen drift inward. Other times, the process is violent, tearing apart smaller galaxies, scattering their stars into ribbons of light. The galaxy you live in today isn't the same one that existed when dinosaurs walked the Earth. And the one your distant descendants may know could be larger still, built from the ruins of countless worlds. The Milky Way is not a monument. It's a story still being written. When stars are thrown free. Most stars travel calmly, but some are flung out at incredible speeds, fast enough to leave the Milky Way forever. These are hypervelocity stars, cosmic runaways. Some are born from violent separations, a binary pair torn apart when one star falls into the central black hole. The survivor is hurled outward, alone, racing into the dark at over 1,000,000 kilometers per hour. They remind us that even within a galaxy bound by gravity, there are rare moments of release, quiet cataclysms that send stars sailing into the emptiness between galaxies. The galaxy grows quieter. Long ago, the Milky Way blazed with new stars forming everywhere, but now that pace has slowed. There's still gas available, but it's thinner, warmer, harder to compress. Star formation hasn't stopped. It's just gentler now, slower, more deliberate. Astronomers say the galaxy is entering its middle age, no longer racing to create, but still glowing softly with purpose. It's not the end. It's a calm chapter in a long, luminous life. Before the disk existed. Some stars in our galaxy were born before the Milky Way had its familiar spiral disk. They live mostly in the halo or thick disk, ancient survivors from the galaxy's earliest formation. By studying their motion and chemistry, astronomers peer back into the time before structure, before the galaxy had form or order. These are the elders of the Milky Way, silent witnesses to its birth and the billions of years that followed. A galactic year. As our solar system orbits the galactic center, it completes one full revolution roughly every 225 to 250 million years. This is called a galactic year, a single heartbeat in the scale of cosmic time. In that span, continents drift, species rise and vanish, and new worlds are born. When we last passed through this same region of the galaxy, the Earth was ruled by dinosaurs. We've completed fewer than 25 galactic orbits since the Sun first formed. We are still young, a small flicker in the galaxy's long unfolding story.
The rules that don't quite work. According to Newton's old laws, stars far from the center of the galaxy should orbit more slowly, just as the outer planets in our solar system move at a gentler pace. But the Milky Way doesn't behave that way. In our galaxy, stars in the outer regions move almost as quickly as those near the core. This shouldn't be possible, yet it is. The reason, once again, is dark matter, an unseen mass that surrounds and supports the Milky Way in a vast halo. Without it, the galaxy would unravel. With it, the stars move together like a single, balanced wheel. We still don't know what dark matter truly is, but we know it's there, a silent architect holding everything in place. Clouds where stars begin. Scattered throughout the Milky Way are immense, dark molecular clouds, the raw material of creation. Composed mostly of hydrogen and a little dust, some of these clouds stretch hundreds of light-years across. Inside, gravity gathers the gas into clumps, pressing it until it collapses into glowing stars. The largest clouds are so thick and cold that they block visible light completely, appearing as black patches in the starry sky. These are the cradles of future suns, the wombs of planets, and the quiet starting points of new worlds. Supernova, the galaxy's storms. When massive stars die, they explode in spectacular supernovae, outshining entire galaxies for a brief moment. These blasts don't just destroy, they create. Shockwaves from the explosion ripple through surrounding gas, compressing it and triggering new waves of star formation. They also scatter heavy elements, iron, gold, calcium, forged in the heart of the dying star. Each supernova is both an ending and a beginning. They stir the galaxy like great storms, spreading light, heat, and the ingredients of life. Dust that hides the light. The Milky Way glows with light we can't see. Everywhere between the stars drifts interstellar dust, tiny grains of carbon, silicate, and ice. To our eyes, these clouds appear as darkness, blotting out stars and nebulae. But behind them, star formation continues, unseen. Infrared telescopes reveal the truth, glowing nurseries filled with newborn suns. What looks like emptiness is often the beginning of something bright. Dust hides, but it also protects, cooling gas, absorbing radiation, and helping the galaxy renew itself. The silent clouds. Not every cloud of gas becomes a star. Across the galaxy, astronomers have found massive, cold, starless clouds, full of hydrogen, but quiet and still. Some are too diffuse to collapse. Others are held steady by magnetic fields or turbulence. They drift through the Milky Way like sleeping giants, heavy with potential, waiting for the right spark to awaken. In them, the galaxy seems to hold its breath. The cycle of everything. Stars are not forever. They live, burn, and eventually die. But their death feeds new life. When a star ends, it releases its elements into space. Supernovae scatter metals. Red giants shed outer layers. Nebulae expand outward, mixing with the gas between the stars. From this enriched dust, new stars and planets are born. Even the atoms in your body were once part of this cycle. Forged in a star, scattered into the void, then gathered again into life. The Milky Way breathes through this endless rhythm of creation and return. The oldest light. Astronomers search for metal-poor stars, stars with almost no elements heavier than helium. These are fossils from the earliest universe, formed before generations of stars enriched space with heavier atoms. By studying their light, scientists glimpse the chemical past,
the conditions right after the Big Bang, before galaxies matured. They are like tiny embers still burning from the dawn of time. Wandering suns. A star's birthplace doesn't always define where it will stay. Over time, gravity and motion can push stars far from where they were born. Some are ejected entirely, racing through the galaxy. Others drift slowly, changing orbits, moving inward or outward. Even our own sun has migrated from its original home. The Milky Way is not static. It's a living current, full of quiet travelers and lost wanderers. Where life might thrive. Just as Earth orbits in a Goldilocks zone around the Sun, the galaxy has its own habitable zone. It lies between the chaotic, radiation-filled core and the sparse, metal-poor outskirts. Here, conditions are calm enough for life to emerge, not too dangerous, not too barren. Our planet sits comfortably within this gentle band, one quiet orbit in a vast ocean where life may not be alone. The moving arms. The spiral arms of the Milky Way look permanent, but they're not fixed structures. They are waves of density rippling through the galactic disk. Stars drift into these arms, shine for a while, then drift out again. The pattern itself moves at a different speed from the stars, like a slow-motion traffic wave. From afar, it looks like order carved in light. From within, it's a dance, a flowing rhythm shaped by gravity and time.
The invisible music. Beyond the light we see, the Milky Way hums with invisible energy. Cosmic rays, high-energy particles from ancient supernovae, pass through space and through you every second. X-rays and gamma rays shimmer from dying stars and black holes. Radio waves ripple from cold gas and pulsars, carrying the faint breath of the galaxy itself. We only see a narrow slice of reality. Beneath that glowing band in the night sky lies a vast unseen spectrum, a silent symphony of energy, rhythm, and time. The giant bubbles above and below. High above and below the galactic center float two immense gamma-ray bubbles discovered only recently. They stretch tens of thousands of light-years into space, ghostly lobes glowing faintly in invisible light. Scientists call them the Fermi bubbles. No one is certain what created them, perhaps a massive outburst from the black hole at the center long ago, or waves of star formation that erupted like fire through the core. They drift quietly now, ancient echoes of violence wrapped in radiance, reminders that our galaxy has a memory deeper than light. Our quiet neighborhood. Our solar system doesn't rest in one of the Milky Way's grand spiral arms. Instead, we live in a small region called the Orion Spur, tucked gently between the larger Sagittarius and Perseus arms. It's not the brightest or busiest part of the galaxy, but maybe that's why we're here. In this calm corridor of stars, supernovae are rarer, radiation storms less frequent. This quiet corner gave Earth the time it needed for life to take root and flourish. We exist in the peaceful pause between cosmic highways. The bar at the heart. Deep in the center of the Milky Way lies a thick, glowing bar of stars, a bright stripe of light crossing the galactic core. This bar rotates slowly, pulling nearby stars and gas into its rhythm, shaping the spiral arms. This bar stirs gas, births new stars, and feeds material toward the black hole at the heart. It's not just a structure, it's the galaxy's beating core, a luminous engine sculpting its own future. A family among many. The Milky Way doesn't travel alone.
It belongs to a small family of more than 50 galaxies known as the local group. The two largest are the Milky Way and Andromeda, cosmic siblings moving slowly towards each other. Surrounding them are smaller dwarf galaxies, faint, fragile, and scattered like children gathered around two great parents. All are bound together by gravity, drifting through the dark in a quiet dance. We are part of that family, widely spaced but forever connected. Bound by gravity's web. Though the galaxies of the local group are separated by millions of light years, they are not drifting apart. Gravity holds them in a slow-motion ballet, curving their paths across the centuries. Some of the smallest galaxies orbit the Milky Way like moons, looping and falling, leaving trails of stars behind. Others move freely, but still feel the pull. Over time, the group may grow closer, galaxies merging, fading, or blending together in silence. Even across emptiness, gravity keeps the family whole. The layers of the disk. From a distance, the Milky Way's disk looks perfectly flat, but up close, it's layered. There's the thin disk, where we live, crowded with young stars and swirling clouds of gas. And above and below it lies the thick disk, puffier and older, filled with ancient suns that orbit on tilted, uneven paths. The two layers tell a story of time, collision, and motion. The Milky Way's disk is not smooth, but textured, like the rippled surface of a great rotating sea. The threads of magnetism. The galaxy is stitched together by magnetic fields, invisible lines that run through the disk and halo, shaping how matter flows through space. They're weak compared to magnets we know, yet across galactic distances they influence everything. How gas collapses, how dust moves, how cosmic rays travel. They rise and twist, looping like invisible currents through a cosmic ocean. We cannot see them, but they hum through the Milky Way, quiet and constant, the galaxy's subtle heartbeat. The space between the stars. Between the stars, space is not empty. It's filled with a thin mist of gas, dust, and plasma known as the interstellar medium. Invisible to the eye, it forms filaments, shock waves, and bubbles, sculpted by stellar winds and ancient explosions. It's not still either. It churns and shifts, mixing and folding like a slow-moving ocean. From this restless fog, new stars and planets eventually emerge. The galaxy breathes through it, not void, but creation waiting in motion. The constant rain of cosmic rays. Every second, high-energy particles known as cosmic rays stream through your body. Launched long ago by exploding stars, they cross the galaxy at near the speed of light, bouncing through magnetic fields and striking atoms in Earth's atmosphere. We rarely notice them, but they are there, silent messengers from far-off cataclysms, reminders that even in stillness, the galaxy moves through us. The imperfect beauty. Despite how we picture it, the Milky Way isn't perfectly symmetrical. One side of the disk is thicker. Some spiral arms are brighter, longer, or more twisted than others. Even the outer warp bends unevenly. These subtle imperfections are the scars of time, marks left by collisions, mergers, and gravitational tugs. They remind us that even galaxies carry wrinkles of history, and that imperfection is its own kind of beauty. The eldest star. High above the galactic plane drifts one of the oldest stars ever found, a dim red light nearly as old as the universe itself. It contains almost no heavy elements, meaning it formed before the Milky Way was even complete. It burns quietly now,
small and steadfast, a living relic of the universe's first dawn.
He, breathing galaxy. The Milky Way is never still. It breathes, not with lungs, but with gravity and light. Gas rises from the disk, cools in the halo, and then gently falls back down like a soft galactic rain. This endless exchange keeps the galaxy alive, a quiet rhythm of creation and renewal that has gone on for billions of years. Through this cycle, stars are born, they live, they die, and their ashes feed the birth of others. Everything that shines now was once part of something that burned before, and everything that burns today will someday become dust again, drifting through the galaxy, waiting to shine once more. The Milky Way doesn't just spin, it breathes. It inhales matter, exhales light, and carries on its slow, patient heartbeat through time. The dust that remembers. Floating between the stars are tiny grains, dust no bigger than sand, yet older than worlds. They carry organic molecules, carbon and ice, the raw ingredients for life. Born in the atmospheres of dying stars, they travel for eons across the galaxy, through cold clouds and warm nebulae, gathering whispers of chemistry wherever they go. Some of this dust may one day find its way into a newborn star, some into a planet, and maybe, just maybe, into a being who looks up and wonders where it all began. Every atom of you, every breath, every thought is built from that same wandering dust. The galaxy remembers itself through you. The dark between the stars. Between the stars lies darkness, deep, ancient, infinite. But even there, the silence is not empty. Invisible waves of radiation hum softly through the void. Magnetic fields twist and shimmer unseen. Gravitational ripples pass, bending space by the width of an atom. What seems still is full of quiet motion. What seems empty is full of memory. Even the dark between the stars is alive, carrying the faint vibrations of all that ever was. The hidden light. Most of the galaxy's light never reaches us. It's blocked by dust, scattered by gas, or lost in wavelengths our eyes cannot see. Infrared, X-rays, gamma rays, invisible colors painting a universe beyond sight. And yet all that unseen light still moves, still touches, still warms. The Milky Way glows in silence, its beauty hidden not because it wishes to be unseen, but because it is too vast for eyes alone to hold. Sometimes, mystery is not the absence of knowledge. It is the presence of wonder. The slow drift of time. Across the ages, the Milky Way changes. Arms twist, stars fade, new ones are born. Its shape ripples, its mass shifts, its story evolves. Even galaxies are mortal in their own way, not ending, but transforming. In a few billion years, the Milky Way will merge with Andromeda. The stars will mix, the shape will change, but its spirit, the light, the gravity, the memory, will continue. Creation never stops, it simply moves to a different rhythm. The last quiet thought. Somewhere in the farthest halo, a lonely star drifts, ancient, dim, and slow. It has seen the galaxy's first light and watched 1,000 others fade. It carries no planets, no companions, only the echo of what once was. And still it shines. Not for an audience, not for meaning, just because shining is what stars do. Maybe that's the secret of it all, to shine quietly, even in darkness.
The sun is middle-aged. The star that warms our world is in its quiet middle years. At 4.5 billion years old, the sun has burned through nearly half of its life. It glows with a steady rhythm now, balanced between gravity pulling inward and fusion pushing outward. Inside, atoms of hydrogen collide at unimaginable speeds, merging into helium, releasing light that takes thousands of years to reach the surface. When that light finally breaks free, it travels 8 minutes across the void and lands softly on oceans, forests, and the skin of every living thing. But the sun will not stay this way forever. 5 billion years from now, it will begin to swell. Its outer layers will drift outward, turning crimson and vast, engulfing Mercury and Venus, brushing the edges of Earth's orbit. What remains will be a white-hot core no larger than our planet, still glowing, still remembering its youth. Every sunrise you've ever seen is a moment borrowed from that long, quiet lifespan. Every ray of light is an ancient promise from a star in perfect balance between birth and farewell. The universe has no edge. When people imagine the universe, they picture a sphere, a boundary, a place where everything ends. But space has no edge, no wall, no border, no outside waiting beyond. It curves back on itself, infinite yet finite, a shape without corners. If you could travel endlessly in one direction, you would never fall off the side. You would pass galaxies, clusters, cosmic filaments, and, after billions of years, arrive back where you began, though the stars would all be older and rearranged. It's difficult for the mind to hold such a picture. We are used to edges, rooms, oceans, horizons, but the universe is more like a vast surface that folds upon itself. There is no center either. Everywhere is the middle, and every observer stands at the heart of creation. The cosmos is not an empty box filled with stars. It is the stars, and the space between, and the expansion that carries them all. Infinity isn't somewhere out there. It's here, woven into the space you occupy. Light from distant galaxies is ancient history. When you look up at the night sky, you aren't seeing what is. You're seeing what was. Light from distant galaxies has been traveling for millions or even billions of years before reaching your eyes. That faint smudge near Andromeda left its home when early humans were still shaping stone tools. Light from galaxies at the edge of what we can see began its journey before the Earth existed, when the universe was still forming its first stars. Each photon is a messenger carrying history. By the time it arrives, the galaxy it came from may have changed completely. Stars born, stars gone, shapes twisted by gravity. We never see the universe as it is. We see it as it once was. To look at the sky is to look through time itself. Every point of light is a memory, traveling endlessly through darkness, waiting to be witnessed once more. There may be more galaxies than we thought. For centuries, people believed our Milky Way was the entire universe. Then telescopes grew stronger and the truth unfolded.
What we thought were clouds of dust were entire galaxies, each with billions of stars. Now modern instruments and deep-field images reveal an even grander picture. The observable universe may hold 2 trillion galaxies or more, each one a city of suns, each sun a possible world, each world perhaps a story of its own. And those are only the galaxies we can see. Beyond the reach of light, beyond the limit of our instruments, the cosmos may continue without end. When you gaze into a dark patch of sky, remember this: in that darkness lies abundance, more light than can ever be counted, waiting just beyond the edge of sight. Space is not completely silent. It's true that sound cannot travel through the vacuum of space. There's no air to carry its waves. But silence is not the same as emptiness. The universe hums constantly, not in audible tones, but in vibrations of energy. Radio waves flow from dying stars. Magnetic fields ripple through nebulae. Cosmic rays strike atoms and send out faint whispers of static. Even the afterglow of the Big Bang fills all of space with a quiet hiss of microwave radiation. If your ears could tune to those frequencies, you would hear an endless background song, the heartbeat of creation still echoing from its first breath. Space isn't silent. It's singing. We just haven't learned the language yet. The universe glows in microwave light. Everywhere you look, between the stars, between galaxies, even in the emptiest reaches, there
The moving heart of the galaxy. Near the center of the Milky Way, stars orbit far faster than those in the outskirts. The core is packed with mass, dust, stars, and the supermassive black holes Sagittarius A. There, stars complete orbits in just a few million years, while out where we live, the same journey takes hundreds of millions. The galaxy spins like a great wheel, but one whose rim trails gently behind its center, twisting its arms in long, graceful spirals. This uneven motion creates the Milky Way's shape, the elegant dance that has lasted billions of years. The waves of creation. The spiral arms of the galaxy aren't fixed trails of stars. They're density waves, slow-moving ripples through space. As these waves pass, they squeeze gas and dust, triggering starbirth. New suns ignite, drift away, and new ones rise behind them, the pattern continuing, timeless and patient. Like ripples in a pond, the arms are not still things, but movements, always changing, always flowing, always alive. From cold to light. Stars are born from cold, collapsing clouds, enormous regions of molecular hydrogen chilled to near absolute zero. Gravity slowly gathers the gas until it compresses, heating the center until nuclear fusion ignites. From the darkest, coldest shadows come the brightest lights. Each new star is a promise, a soft flame born from silence. The bonds that fade. Many stars are born in clusters, families of hundreds or thousands bound together by gravity. But over time, they drift apart. Tides from the Milky Way, passing stars, and the motion of the galaxy slowly pull them away from one another. Even our Sun was once part of such a cluster. Its siblings now scattered across the galaxy, lost in the haze of distance and time. Somewhere out there, our solar family still shines, faint, distant, and forgotten.
The rarest of the old. Among the halo's quiet wanderers lie hyper-metal-poor stars, ancient lights that contain almost no elements beyond hydrogen and helium. They are relics from the first era after the Big Bang, pure, untouched, and unimaginably old. Each one is a message from the dawn of time, still burning softly, still here. A galaxy of worlds. Planets are everywhere. Every time a new star forms, a swirling disk of dust and gas surrounds it, the birthplace of new worlds. Across the Milky Way, billions of solar systems orbit their stars, some vast and wild, others quiet and small. The galaxy isn't just filled with stars, it's filled with possibilities, endless, waiting, and alive. The gentle rhythm of the sun. As the sun orbits the galaxy, it moves in a soft wave, rising and falling above and below the galactic plane, like a cork floating on a slow ocean. This oscillation takes tens of millions of years. Some wonder if this subtle motion might even influence life on Earth, though the truth remains uncertain. Still, it's comforting to know, even as the sun glides, it sways softly, gracefully, forever. The unknown weight. We don't know exactly how massive our galaxy is. Most of its weight lies not in the stars we see, but in the dark matter halo surrounding it, unseen, silent, but essential. It might be 1 trillion times heavier than the sun, or more. Even the Milky Way's gravity is still partly a mystery. But that mystery, that not knowing, is part of its beauty. The river of light. From Earth, we can't look down on the Milky Way. We see it from within. That glowing river across the night sky is the edge-on view of our galaxy's disk, filled with countless stars packed into a narrow band. We live inside the story we try to understand. Like standing in a forest, looking along the line of trees, we see only the depth, not the shape. It took centuries for humanity to realize we are part of this spiral, not outside it. We belong to it. The universe in us. Even the emptiness between stars is alive with motion and memory. Light travels, stars are born, dust gathers, and worlds form, again and again, in endless renewal. And within all of that, within the great turning of galaxies and the glow of distant suns, are the atoms of you. The iron in your blood, the oxygen in your lungs, the calcium in your bones, all forged in ancient stars. You are not separate from the galaxy. You are its continuation, a living expression of its long, luminous story. And now, as the stars fade behind your thoughts, the journey slows. We've drifted through the spiral arms and wandered into the galaxy's heart. We've seen how stars are born, how they die, and how their dust becomes us. You are a part of this, a small warmth in the dark, a single light resting in a sea of stars. So let your mind drift. Let the weight of the day fall away. The galaxy turns softly around you, patient, radiant, eternal. If you're still awake, you can go ahead and watch the next story now.
But if your eyes are heavy, just rest. Sleep well, dream softly, and remember, you are made of stars.